So this will be video assignment 2 for Physics 251, going over a homework problem that we had some difficulty with. And personally, I chose one from the latest homework since it would be the most relevant at the time. And since we move so far into the chapters, I believe, of course, it gets harder and harder as you go. So it's pretty fitting to start with one of these questions. So the problem I chose was from homework number 7, and it was number 3. And the problem states, a figure skater is spinning with an angular velocity of positive 17.8 radians a second. She then comes to a stop over a brief period of time. During this time, her angular displacement is positive 5.2 radians. Now, we're looking for her average angular acceleration, as well as the time during which she comes to rest. So, I've laid out at this second point the things that we should be looking for, because I think whenever you go about tackling a problem, you should lay out the things that you know and the things that you don't know. So, what we're looking for, we need to find her angular velocity, what her angular displacement is, and what are the symbols that we use for velocity, displacement, and speed. And we're also going to talk about how they differ from normal velocity and displacement, because they do use different symbols, which could confuse students if they aren't aware of the difference. So, we'll cover the points that I had, kind of some hang-ups that I had. So, I didn't remember the equations for either of what it was asking, so I had to spend a little more time researching the problem, looking in my book, and finding out what equation I should use to find the info I'm trying to get. So next, when I figured out said equation and started plugging in my work, I'm not exactly sure if it was Wiley plus, the software acting up and not accepting my answer, or if it was just user input on my end. But for part B of the problem, I was not able to solve it in all 3 attempts, and I knew I had the right answer because I ran the algebra through. I know I did everything right. I got my positive and negatives all correct, and I by all rights, I should have had that problem. So that was one of the biggest issues I had with it, be it me or the software. Solving the problem was mildly complex in itself, but after finding out the formula and drilling in the values, it became a little bit easier. So, we're going to cover the symbols that we should be looking for and using in this equation, and their differences compared to normal velocity and stuff. So, the first thing that we'll cover is the angular velocity, which is represented by that little W symbol. I'm not exactly sure what the Greek word for it is, but it's a little W. And usually, like in past chapters or homeworks, velocity has been represented with a V, lowercase or capital. Next, we're going to talk about the angular displacement, which is going to have the symbol theta. And this is different from normal problems where we'll use S or D, like the distance that somebody covers. And angular acceleration is that little fish symbol, I like to call it. I'm not exactly sure what the Greek letter for it is. But with acceleration, we usually use a lowercase a or a bar to represent your normal acceleration, be it a ball or a car moving. All right, so now we go into solving the problem. We have our known variables. So what we do first is we look at the problem, and you take a piece of paper, and you write down what you know, as well as the formula if you know it. So, our known variables, as you see in the second point, are the final angular velocity, which is our tiny w, and that's going to be 0.0 radians a second, because once she comes to a stop, her velocity is going to be 0. Her initial angular velocity is going to be represented with the little w and a circle, so we could call that WO or whatever you'd like to call it. And that's going to be positive 17.8 radians a second, because that's the angular velocity she's moving at in a positive direction. And lastly, we know our angular displacement when she stops, which is positive 5.29. And that's going to be represented with our theta. Now, moving on to our dot 3, we also need to put the formula to solve for angular acceleration, our little fish symbol. And that's going to be represented as little fish symbol equals W naught squared divided by 2 times theta. So once we get to that point in the next slide, I'll explain further how to plug our data into that. Next, once we find that information up there, we're going to solve for the time it takes for the skater to come to rest, which time is going to be represented as negative W naught over the little fish symbol, which we solved for up there. So what that means is we can't solve the rest of the problem without finding out our angular acceleration. And that could be a hang-up for some students if they don't know how to solve for it. Now, these are going to be our unknown values. So, obviously, we know we have to solve for angular acceleration and the time it takes for her to come to a stop. So our unknowns are the little fish symbol and time. Now, to solve for our angular acceleration, our formula that we're going to place it into is angular acceleration equals negative 17.8 radians a second squared positive divided by 5.29 radians. That's our theta. 5.29 is the theta value, and once you solve this equation, that gives you negative 29.9 radians a second. Since both values, top numerator and denominator, are positive, and we have that negative symbol, it turns it into a negative. And lastly, once we find our angular acceleration, which again is negative 29.9 radians a second squared, we'll solve for our time, and that's going to be 17.8 radians a second divided by our angular acceleration, which is negative 29.9 radians a second squared. And that gives you a value of 0.594 seconds. And that's what I plugged into the problem, and I'm not sure, or actually I plugged in 0.59, but that shouldn't be an issue, I wouldn't think. So maybe it was my error for not putting it to the third decimal or third significant figure, but Wiley Plus would not accept that answer no matter what I did. Now, covering all that, a little advice that would be good for solving these problems. I have 3 points here. So our first point would be giving the formula. So of course, if you have the formula, it's way easier to just plug in your info. And of course, memorizing a bunch of formulas can be time consuming or even troublesome for some people because they may not have the best memory when it comes to that. Our second point is helping people solving the problem. I'd inform them that they need to write down the info that they have in the question. So we start with our known values, and then we pair it up with the symbol that it should match with. And that'll help us later on plugging it into the formula that we should have from the first one. Now, my last point is once you know all your knowns, which hopefully is known, it's pretty much simple algebra and division solving the problem. But knowing how positive and negative symbols is going to really mess up what you'll be getting in the end. Like as before for the angular acceleration, if you weren't very good at knowing how to plug in your positive or negative numbers, then instead of getting negative 29.9 radians a second squared, you'd get positive 29.9 radians a second squared, and that would mean she's moving faster instead of, or excuse me, I'm not quite sure where I'm going with that, but if you don't know how to use your negative and positive symbols, you'll mess up the problem and you won't be able to solve further on down the line, because if you use that positive value, your solving for time would be skewed as well, since you were using a positive instead of a negative. Okay, well, that's going to conclude my explanation of the problem, and hopefully you have a good morning or evening, whichever time you're watching this at. Thank you, and goodbye.